The Brinell Hardness Test is widely used for assessing the hardness of castings, forgings, and non-uniform materials. It provides an average hardness over a large area, making it ideal for inspecting raw materials and heavy components. The test involves using a Brinell microscope to measure the indentation left by an indenter. Brinell hardness testing adheres to several standards, including the Indian standard IS 1500, ASTM standard ASTM E10, and ISO standard ISO 6506. These standards ensure consistency and reliability in hardness testing across different materials and industries. The principle of the Brinell test involves pressing a hardened ball into the material under a known load. The indentation diameter is then measured using a microscope. Hardness is calculated from the applied load and the indentation area, providing a clear measure of material strength. Unlike the Rockwell test, which measures depth, the Brinell test measures indentation area. Although Brinell is slower, it offers a more representative value for coarse structures, making it a preferred choice for certain applications. The Brinell testing procedure involves selecting the ball diameter and load as per the material, applying the load for a specified dwell time, and measuring the indentation diameter in two directions. The Brinell formula is then used to calculate hardness, ensuring accurate results. To gain a clearer understanding of the Brinell hardness test, watch the video for a detailed explanation of the process and its applications.
We are going to test a Brinell hardness specimen. A 10 mm diameter ball indenter has been selected as per the test requirement. Place the specimen properly on the anvil and set the test load to 3000 kg force. Now apply the load gradually until the machine takes over and automatically applies the full load up to 3000 kg force. Now apply the load gradually until the machine takes over and automatically applies the full load up to 3000 kg force. Maintain the load for the specified dwell time. After the dwell time is completed, unload the specimen carefully. Measure the diameter of the indentation using the Brinell microscope. The observed indentation diameter is 5.33 mm. Enter this value into the machine, which calculates the hardness as 124.1 HBW 10/3000. This value can also be verified from the standard tables given in ASTM E10, corresponding to a 10 mm ball indenter and 3000 kg force load, based on the measured indentation diameter.
The Brinell test is advantageous for heterogeneous materials and castings due to its ability to leave large indentations. However, it is not suitable for finished parts, as the indentation can affect the surface quality. Hardness is reported as HB or HBW, with an example being 192 HBW 10/3000. This indicates the hardness value, the type of ball used, and the load applied. Different combinations can be used depending on the material's hardness or softness. In Brinell testing, the applied load is selected using a constant ratio of p/d squared, where p is the applied load and d is the ball diameter. This ensures consistent results, with larger indentations indicating softer material and smaller indentations indicating harder material. Thank you for watching this presentation on the Brinell hardness test. We hope you found the information insightful and useful for your applications.